Good day and welcome back to the Johnson Space Center as our pre-flight briefings continue for Discovery's upcoming flight to the International Space Station. This is the mission overview briefing. With us today to discuss all of the details of this flight are Brian Lunny, the lead Space Shuttle Flight Director for STS-133, and Royce Renfrew, the lead Space Station Flight Director. And we'll start off with Brian.
Let's see. Good morning, folks. We're excited for this upcoming mission. I'm really grateful that all of y'all have taken the time out of your day to come talk to us about the mission. Hopefully we'll fill in all the questions that are in your minds and be able to help you understand what's coming on this mission. If I could have the crew picture of the crew up there, we'll talk about the crew who's flying. We have a great crew. They've flown numerous times before as a group. We're looking forward to working with these guys. We've had some great training sessions over the past number of months, and they're a great group. Starting with the picture on your left, we have Al Drew. He's flown once before in STS-118. This time around, he'll be one of our two spacewalkers. And while he's not out doing spacewalks, he'll be inside helping with everything else. Particularly, he'll be assisting with the shuttle RMS operations during the Flight Day 2 inspections, the Express Logistics Carrier installation, and also the Flight Day 10 inspections. And we got him doing a bunch of other things as well. Next to Drew is Nicole Stott. She, of course, has been a flight engineer on Expedition 20 and 21. She flew up on STS-128 and flew back on STS-129, so she's an experienced flyer all around. She will be performing robotic ops with the station RMS for installation, excuse me, for installation of the Express Logistics Carrier as well. And she'll also be doing the coordination of the spacewalk tasks from inside. So she'll be walking the crew outside through all their tasks, every little detail you'll hear her telling them, reminding them what they're supposed to be working on. Next to Nicole is Eric Bowe. He's our pilot on this mission. He is a pilot from STS-126, so he's flown once before. Eric will also be performing robotic ops with Shuttle RMS during the Flight Day 2 inspections, the Express Logistics Carrier install, and the Flight Day 10 inspections. He is also scheduled to help us with the permanent multipurpose module outfitting. Once we get it installed, he'll go hook up all the wires and plumbing to make it work for us. And that we expect that activation to occur about Flight Day 7. We may shuffle that a little bit earlier if things go well. Eric will also pilot Discovery during the undock and fly around at the International Space Station on Flight Day 10. Next to Eric there in the middle is Steve Lindsay. Steve, of course, is a very experienced flyer. He was pilot on STS-87 and STS-95. Then he was commander on STS-104 and 121. Of course, he will fly the rendezvous for us, and he will be assisting with the shuttle robotic operations as well, and he'll be available for a lot of other tasks throughout the mission. Fifth from the left there is Mike Barrett. This is Mike's first time to fly up on the shuttle. When he was an expedition crew member on 19 and 20, he flew up on the Soyuz. Once up in space there, he will perform a lot of the space station robotic operations for us during the Express Logistics Carrier installation, the permanent multipurpose module installation, and also while the spacewalkers are out doing their business out on the outside the vehicle, he'll be flying the station robotic arm around, helping them get to various locations. And finally, on the far right is Tim Kopra. He flew up on STS-127. He was a flight engineer on Expedition 20, and he swapped seats with Nicole on STS-128. She stayed, he came home. Tim will be the other one of our spacewalkers on this mission. He'll be performing robotic ops also with the station RMS for installation of the ELC and the permanent multipurpose module. These guys, like I said, are a very experienced crew. They've been having great training so far, and we know that they're all ready to go and fly this mission. They're in good shape to go fly. If I could get the crew patch up, we'll talk about that for a minute. This is a really neat crew patch, I think. It was designed based upon some sketches from the late artist Robert McCall. They were the final creations of his long and prodigious career. It shows Discovery lifting off with the plume beneath it, but there's no external tank and no SRBs, which is just representing sort of the tail end of the program, I think. But it's a sort of a retro patch, I think of it as, and I think it looks really, really nice. I like this patch. Let's see. If I could, we're going to talk a little bit now about some of the folks on the ground who will be helping the crew from get through their daily operations. If I could have the picture of Mr. Jones up. Richard Jones is our Ascent Flight Director. He's known as Sigma Flight. This will be his 4th ascent. And of course, Richard, he's very experienced. He's ready to go. He'll be doing his final simulation with the ascent team next Tuesday, and then they will be ready to go fly, help the crew get off the ground on ascent day and turn that vehicle from a rocket launcher into an orbit operations vehicle. Next slide, please, with Ginger. Ginger Carrick is a Vega flight. This will be her third flight as a shuttle flight director. She's done numerous things on the space station side and still is doing those things. Ginger will be on the Orbit 2 team, which is the team that's sort of in the second half of the crew day. So after lunch or thereabouts, she will take over with her team and help the crew through the spacewalks and the other operations during that phase of the day. Next slide is Rick LeBrode. Rick is a Pegasus flight. This will be his 8th flight as a shuttle flight director. He too has worked a lot on the station side and also on the shuttle side. He's a very experienced flight director. Rick will be working the planning shift, which will be the overnight while the crew's sleeping, and they will work any replan efforts that might be required, but basically get the plan on board for the next day for the Orbit 1 and Orbit 2 teams to go execute. And then finally, on the shuttle side, I'll mention Paul Dye. Paul is our Team 4. Of course, Paul is Iron Flight. He's very experienced. Y'all have seen him numerous times as a lead. He will be, the Team 4 folks are there just in case we have some issues, and they can come in. We had pre-identify a Team 4 folks to come in and work any issues that may come up that the flight control team may need a little extra help with. So we're excited to have Paul helping out with that. Hopefully we won't need him, of course, but he'll be available if required. Let's see, and last but not least, for entry, for the final landing there of Discovery, we have Tony Sakachi. He is Intrepid Flight. This will be his second flight as an entry flight director. Of course, he has numerous leads also and has been in the shuttle program, I think since STS 1. So he's been around a long, long time and very experienced and brings a lot to experience to the console. And we're really glad that he'll be helping us out with the entry phase of this flight. Finally, for myself, I'll of course be Orbit 1. I probably should have mentioned that already, but my team will be working the first half of the crew day. We'll get there about the time the crew wakes up, and we'll be leaving around midday when the crew is going to bed. Now I'll walk you through a few of the things in the payload bay. If I could get the video for the payload bay. There we go. This is Discovery's payload bay. It shows all the elements in there. Up towards the front of the vehicle is the orbiter docking system. That, of course, is what we dock to the International Space Station with, and the crew will use that to transfer between the vehicles once it's pressurized after docking. There in the port sill is this shuttle remote manipulator system. That's our robotic arm we'll use for numerous robotic operations throughout the flight. And the orbiter boom sensor system is on the far side there on the starboard sill, and we'll use that to inspect Discovery's heat shield. The Express Logistics Carrier number 4 there is in the middle. It's to carry ORUs for station, and that's the radiator sitting on it. I'm a little behind the video here. And the permanent multi-purpose module is there. You may recognize it as formerly known as an MPLM. We call it a PMM now. We're going to take it up. We're going to leave it on board International Space Station. So let me walk you through the flight days. I'll get the first 3, then I'll hand over to Royce and let him work on the rest. Of course, we're going to launch on November 1st. It's about 3:40 in the afternoon here in Houston, the time of launch. We're looking forward to that, ready to go. Mr. Jones will come in with his team, and they'll be ready to go execute and get the Discovery off the ground. Once ascent is complete and we've turned the vehicle over into an orbit machine, got the payload bay doors open, they'll begin downlinking, and we're reviewing our ascent imagery, of course, and pick up with some of the standard sort of Flight Day 1 activities. These include, we'll downlink all the video from the ET and the umbilical wells. We got some sensor data to play back. And the crew in general is going to be just configuring the cabin, putting away some seats, getting the cabin ready to go for orbit ops, and also pulling the arm out and doing a brief RMS checkout to make sure it's in good shape for the next day's activities. On Flight Day 2, the crew will wake up, and if I could roll the video of the inspection, please. There we go. I think y'all may have seen this before. This is the inspection video. They'll pull out the arm and they'll do scans starting on the starboard side and the aft, just looking for any ascent damage that may have occurred. And we'll do a pan tilt survey there of the back end, including the OMS pod, checking for the thermal blankets and the towels and the T0 umbilicals, making sure everything's in good shape after ascent. And then they will maneuver forward and they'll do several racetrack patterns, scanning the reinforced carbon-carbon along the leading edge of the wings there, making sure those things are in good shape and that no damage was incurred during ascent time. This process takes about 6 hours, so it's much of the crew day on flight day 2. The wings each take a couple of hours each, and then they spend the balance of the time working on the nose cap and the other surveys. And the crews train this a lot and obviously ready to go execute. It's the same survey we've been doing for several flights now. With all that data that is coming from the ascent team, from the ascent imagery on the ground that we downlink from the orbiter post-launch, and then this data, and as well as the R-bar pitch maneuver, all that data is going to be reviewed by the teams on the ground. The debris damage assessment team will gather all that data, and they'll look at it and compare it to baseline data. They're looking for any damage that may have occurred during ascent to be sure that the vehicle's in good shape. And after about a day and a half, sometime around when the crew's going to sleep on flight night 3, they'll be able to report to us if they require a focused inspection. So if they see something of concern, they want to get a better look. We got some specific instruments on that orbiter boom system for that. We'll go and have a look at any area that they might be concerned about, and we would do that on flight day 6. If that's not required, of course, we get a clean bill of health from them. We'll be very excited. And that, frankly, is our anticipation that the vehicle will be in good shape. Once they tell us after flight night 3 if a focused inspection is not required, that team, the damage assessment team, will continue to do their reviews and then report to the MMT after a couple more days, probably of more rigorous analysis, comparing all the baseline, making sure everything's just completely good. They will report to the MMT their report, and based on that, we hope to be able to clear Discovery's TPS to be safe for entry. And of course, you'll hear that from the folks when we come back in here on those days. I know you guys have followed these debris assessment, damage assessment things from flight to flight to flight. And lately, they've been very, very clean, and we're very excited about that and have every expectation that this one will come back just the same, very clean. And we'll be able to execute the rest of the flight nominally. Let that video play out. Once they're done with the scans, they're going to go ahead and park the OBSS. They'll put it back in its place on the starboard sill, and then they'll put the RMS, shuttle RMS, over in a pre-cradle position, getting ready for docking on flight day 3. For this inspections, of course, I mentioned them already, but I'll say it again. Steve, Eric, and Al are all trained and qualified and ready to go execute these inspections. And we'll see which one of them actually flies the arm, who helps, and which roles they play. But I expect they're going to swap out a little bit as they go. And there you can see in the videos being parking the arm, ready for flight day 3. Excuse me. So again, overnight, flight day 2, we're looking at all the data. The ground team, the engineers on the ground are rigorously analyzing it, making sure that Discovery's in good shape. Heat shield is in good shape. At the same time, the morning of flight day 3, we're going to wake up, get the crew ready to go rendezvous with the International Space Station. The crew should wake up about 40 miles short or behind the International Space Station, and we'll execute a series of burns to bring us up closer. And if I could roll a video of the approach and docking. And as they're coming in to the International Space Station, you can see them coming up from the bottom there. Commander Lindsay will stabilize the vehicle on the R-bar, which is just directly beneath the International Space Station, about 600 feet or so. And he'll do a R-bar pitch maneuver. And the folks on board the International Space Station will take a bunch of pictures of the TPS on the bottom, being sure that the tile there is in good shape. They'll get several pictures of each location, and with the 408mm lenses that they use, they will get really good pictures. And again, the damage assessment team will go and review all those pictures from the different angles that the pitch maneuver actually enables, and be able to determine a whole lot of data about the health of the underside of the vehicle. And again, report back to us on the night of flight night 3, then a couple days later. And then we'll fly up to the V-bar. It takes about 10, 11 minutes to fly up there. Then Commander Lindsay will fly it down the V-bar corridor, approaching the International Space Station from out in front, so to speak. And then he'll pause at about 30 feet and do any fly out that might be required if there's any slight misalignment, a degree or two. He'll be able to do that. And then press on in from 30 feet for the docking with the International Space Station. Once we are docked, the crew will commence with their hatch leak checks, make sure that the seals are all clean and holding pressure, and then they'll be able to open the hatches, go into the International Space Station and greet the crew on the other side. They will have a safety brief, and then they'll pick up with their activities with the International Space Station for Flight Day 3. And as I said before, it's a busy day. Half of it's done, the second half is coming, and Mr. Renfrew here is here to tell you about the second half.
Good morning. So 133 from an ISS perspective represents the last pressurized module we have scheduled to bring up, and also the exposed logistics carrier number 4 coming up. PMM will provide us with some much needed stowage space once we move all of the equipment out of the PMM into the various locations on ISS that it comes uphill with. There's some good science and lots of spare parts in there, and then once we get the module cleared out after 133 departs, we'll move other equipment into the permanent multi-purpose module. That is equipment that we don't normally have to get hands-on very often. It's been a pretty busy traffic pattern on board ISS, as it has been for the last couple of years. On October the 10th, we docked 24S with our last 3 ISS crew members that came up. On Tuesday of next week, 37 Progress will undock from DC-1, and then on Friday of next week, 40 Progress will dock to DC-1, bring up additional materials in that vehicle. And then also after 133 undocks, the 23 Soyuz vehicle will undock at the end of November. I should point out, and I think it's been mentioned a couple times in the conferences already, that November 2nd represents 10 years of continuous human presence on board ISS. Some trivial pursuit facts and figures for you. On November 2nd, we will have had 68,519 total orbits since the first Element launch, and we'll also have had 57,361 total orbits with humans on board ISS. Some of the prep work that's gone on to get ready for the mission: we've installed a power cable in the lab that will allow us to provide power to the permanent multi-purpose module once we get it installed on the Node 1 Nadir port. We've also checked out the starboard lower inboard common attach mechanism where the express logistics carrier, number 4 is installed. Done a lot of work in the airlock, recharging various batteries. We've also moved the 4 spacesuits that we usually keep on ISS out of the airlock into other locations on ISS. 133 will bring up its own spacesuits, and we'll put them in the airlock after we get docked. We've moved the special purpose dexterous manipulator onto its location for 133, which is the lab base point. And we've also gotten the space station remote manipulator system, the Canadarm2, walked off to the Node 2 base point. We still have 1 mobile transporter translation to do that on Friday and get the MT to worksite 3 for its start point for the mission. Crew's also spent a lot of time. Brian showed you the pictures of the R-bar pitch maneuver from his perspective. The crew has spent some time on board reviewing those procedures to be able to take those pictures with those 400 and 800 millimeter lenses to make sure we get all the orbiter TPS inspections done. And we've moved some stowage, and actually Brian and I were just in a tag up with the crew when before we came over here. We've had several tag ups with the crew and several more scheduled before we launch. Speaking of the crew, if I could get the crew slide, please. 6 crew members on board ISS at this time. From your left to right, we have Oleg Skripochka, Alexander Kaleri. Alexander is one of the most senior astronauts, cosmonauts in the world. He has numerous missions that he has executed. Then on the far right, we have Fyodor Yurchikin. The 3 Russian crew members during the 133 mission will spend some time preparing for Russian segment EVA using their Orlan spacesuits, which is going to occur shortly after 133 undocks. So they'll be doing essentially the same activities the U.S. crew members have been doing this week in preparing their spacesuits to go out. Third from the left there, you have Scott Kelly. Scott will be the ISS commander for increment 26 after Doug Wheelock leaves. A couple of activities Scott will perform for us. He has CEDRA, which is the carbon dioxide removal assembly. And we're going to bring up an absorbent bed to replace in CEDRA, so he's going to do a majority of that activity for us. There's also a valve in the Columbus module in the internal thermal control system that we're going to R&R, and Scott's going to perform that. And he is also responsible for getting the Node 1 Nadir vestibule outfitting done along with shuttle pilot Eric Bowe. Next to Scott there, you see Doug Wheelock, who is the increment 25 commander, the current commander of the vehicle. Doug will also help out with that carbon dioxide removal assembly bed R&R that we're going to perform. And he's also going to make sure we get all the EVA camp out prep and post activities completed as well. Next to Doug there is Shannon Walker. Shannon has various in-flight maintenance activities that we're going to perform on 133 with either items that we're bringing up on the vehicle that we need to get installed on ISS or items that we want to bring home on 133 that she's going to take apart for us. She's also spent the 3-stage EVAs flying the station arm, so we're going to use her expertise in that area to work with Mike Barrett during the 2 EVAs where we're flying a crew member on the arm. Shannon also has a couple of individual unloaded arm ops that she's going to do for the various walk-offs that we need during the mission. If I could get the first flight director slide, please. We'll roll out of the crew overview, and I'll tell you the folks that are on my team on the ground. First person there is David Korth, who's Odyssey Flight. Dave's the other execute shift flight director. He gets the Orbit 1 shift, which is essentially the first part of the crew day. That'll include EVA prep on flight days 5 and 7, and also all the activities that are associated with the morning ops, which includes the permanent multi-purpose module installation on flight day 6. You've seen Dave as the STS 119-15A ISS Orbit 3 flight director, and he was also recently the Increment 2122 lead ISS flight director. If I could get the next slide, please. Chris Edelin is the Orbit 3 ISS flight director, the planning shift. Chris will be responsible, Chris is Venture Flight, by the way. He'll be responsible for making sure any changes to the plan are taken care of that we might need based on real-time decisions during the mission. He'll also be responsible for a lot of those robotics ops I've alluded to that are going to occur when the crew is asleep and the ground is driving the arm or the MT from the ground. A lot of that will fall on Chris's shift. You've seen him recently as the shuttle Orbit 3 flight director for STS 130, which was ISS 20A, and he was also the shuttle Orbit 1 flight director for STS 132, which is ULF 4. Next slide, please. Kwatsi Alabarujo, Defiant Flight, will be our ISS Team 4 flight director. Kwatsi's a veteran flight director with numerous missions. His last 2 leads have been the ISS lead flight director for STS 119, which was 15A, and he was also the shuttle flight director lead for STS 130, which was 20A. Going to go through a couple snapshot configs of the vehicle as we work through the mission, and then I'll talk about the 2 components we're going to install, and then we'll get back to the flight day overview. So if I could get the first overall config. This is what it'll look like after Discovery gets docked to the ISS before we start any of the installations. And then on the next slide, you can see ELC 4 installed out on the starboard truss. We'll do that on flight day 3. And then the next slide, please. Here's the location of the permanent multi-purpose module docked to Node 1 Nadir. And then if I could get the next slide, please. Here's what the ISS will look at after we're finished with the mission and we're back free flight. The permanent, let me spend a little bit of time talking about the permanent multi-purpose module and what it is and how it wound up here. If I could get the exterior shot of the module, please. Here you see what's called the permanent multi-purpose module, and the red area over there is where it's located on Node 1 Nadir after we get it installed. As Brian mentioned, this is actually a multi-purpose logistics module that has flown to ISS numerous times. The last time it was on board was during STS 131, which is 19A. This is the Flight Module 1 Leonardo module. After we got it back from that mission in April of 2010, we upgraded some of the exterior micrometeoroid orbital debris shielding, and we also changed some of the components inside to make it easier to do on-orbit maintenance and updated the software on it, got it ready for a long-duration mission as opposed to the short turnaround MPLM flights. If I could get the next slide, please. Inside the module, again, you'll see as I go through these slides here, it comes uphill pretty much packed. One of the items that we're bringing up in the Bay 1 area is a treadmill replacement for the treadmill 2 or the Colbert treadmill. If we have any problems with that, we're bringing up a spare treadmill inside the permanent multi-purpose module. If I could get the Bay 2 slide, please. Here you can see where part of the Robonaut will be located. This is the stand that it sets on once we get it deployed in the lab. Then in Bay 3, We have Express Rack number 8, which is a payload rack. We'll get it out of the permanent multipurpose module after the mission, get it installed in the other modules and get it activated. It's a science rack coming uphill. And then if I could get Bay 4, please. Bay 4 shows the upper torso, where the upper torso of the Robonaut will be stowed going uphill. And again, after the mission, we'll get those 2 components out, get those put in the ISS and activate that. And then the last slide shows the in-cone configuration with a couple bags around the outside radius of the in-cone. After we've cleaned out a lot of stuff in here, we'll build what the crew likes to call a bungee jail by stringing bungees between the racks in Bay 4 and creating essentially a spider web back there where we can put some light items in the in-cone of the PMM for additional stowage. So that's the permanent multi-purpose module, and then I'll tell you just a little bit about Express Logistics Carrier number 4. So if I could get that slide, please. Here you see both sides of Express Logistics Carrier number 4 as it's configured to go uphill. The bottom of the image as you're looking at it there would be the piece that attaches to the truss. If you look along the bottom of the image in the left side view, you see 2 grapple fixtures that the various manipulators will get a hold of. And then on the top in the left and the right side view, you can see a 3rd grapple fixture, and I'll explain to you in a few minutes why we have 3 grapple fixtures on Express Logistics Carrier number 4. Going uphill, we have the radiator that you saw when Brian showed you the payload bay overview. This is a spare radiator. We've seen after the pump module failure recently how important it is for us to have in situ spare parts on board ISS, so this will be a spare radiator for the external thermal control system if we ever need it. Then on the right-hand side, you can see that I have 5 empty flight releasable attachment mechanisms, or FRAMs. Those come uphill empty, and then on subsequent flights like HTV that I have designated here, we'll put various components in there, like the flex hose rotary coupler and the common transport carrier number 4 that go in those 2 positions. So we left off with ELC 4. Flight day 3, after we get the crew across the hatch and have completed the safety briefing and the welcome ceremony, we'll get down to installation of the external logistics carrier, Express Logistics Carrier number 4. We will be using the bottom handrails, we'll be using the trunnion grapple fixtures I showed you there, and I have a little video that I can show you. I said I would explain why there are 3 of them on there. Tim and Nicole will be flying the Canadarm2. Al and Eric will be flying the shuttle arm for this activity, and then Al and Mike will actually operate the common attach system once we get it installed. So if I could see video 1, I'll walk you through the installation of ELC 4. Start out with the station arm, reaches into the payload bay and grapples one of those grapple fixtures I pointed out to you earlier. Then we will maneuver to what's called a high hover position and then translate starboard to allow to present a grapple fixture for the shuttle arm to take the payload away from us. Then the shuttle crew will operate the RMS, reach over and take the payload away from us using the second grapple fixture that I pointed out to you earlier. Station arm will release and maneuver to the mobile remote service or base system where we'll grapple. While we're doing a walk-off, the shuttle arm will maneuver the payload and present the third grapple fixture to us, which is in a convenient place for us to get a hold of. From the ground, we'll change the ends of the arm, and then the station crew will pick back up, operating the Canadarm2 from the cupola in this case. Grapple the ELC-4, then we'll perform what's called an operator-commanded auto sequence, which is just a really big maneuver that will run in automatic. There is a camera on the end of the ELC that allows the crew to get good cues when we come in. We'll come into a low hover and then a pre-install, and then we'll install it with Al and Mike operating the common attach system. After we get done, we will release, and then overnight, I will mention that I mentioned Chris is going to be doing a lot of robotics ops with his team overnight. Overnight, we'll walk the arm off from the ground back to the Node 2 base point to set up for the orbiter room sensor system handoff that occurs in the morning of the next day. So flight day 4, again, we have the handoff. Mike and Nicole will be flying the station arm, the Canadarm2, with Steve, Eric, and Al all having some portions of the shuttle robotics during the OBSS handoff. And if I could get video 2 here, I'll walk you through this. Station arm grapples the orbiter boom sensor system out of the payload bay, maneuvers to a hover, and then presents a grapple fixture to the shuttle arm. Shuttle arm will grapple, station arm will release, and then the shuttle arm will maneuver the boom to a clearance position. The shuttle arm will hold the OBSS for the remainder of the mission for doing all of those, any late inspection surveys that we need to get done. Also on flight day 4, we're going to take the carbon dioxide removal assembly out of the air revitalization rack in node 3 and get that in a temp stow location in the GEM module in preparation for the CO2 bed R&R later in the mission. Also on flight day 4, I mentioned Scott will go into the Columbus module and we will take out a water on-off valve. It's water on-off valve number 8, which is a valve that's contained in the Columbus internal thermal control system. That valve has failed in an open config. We're bringing up a spare valve on the mission. We'll change that out, bring home the failed valve on 133. Lastly, we'll get the crew into camp out. Tim Coper and Al Drew will spend the night in the airlock in camp out in preparation for flight day 5, which is EVA 1. If I could get the EV crew overview, please. So here you see our 2 spacewalking crew members, Tim Coper on the left, Al Drew on the right. Tim Coper will be the lead spacewalker for both EVA 1 and EVA 2, and Al Drew will be EV 2 on those two activities. These will be Tim Coper's second and third spacewalks, and this is Al Drew's first and second spacewalks. Art Thomason, who is the lead extravehicular activities officer for 133, has an extensive briefing for you folks later on today where we'll go through and talk about what we're going to do on both the EVAs. So I'm just going to hit a couple of the high points. We have what's called the J612 connector, and the name just derives off of the schematic that shows which cable socket we're going to plug it into. So we have the J612 connector cable. It's a 10-foot extension that we're going to plug into the end of node 1 that'll get that power source out from underneath the permanent multi-purpose module once we get it installed on flight day 6. We will also go get the pump module that the expedition crews have located into the POA on the previous stage EVAs. The POA is the payload ORU accommodation. That's a part of the robotic system out on the mobile remote servicer system. We'll go get that failed pump module and relocate that to ESP2. There is a camera stanchion that is located close to where we installed Express Logistics Carrier number 4 yesterday, and we need to actually move that camera stanchion out of the way in order to be able to access those 5 flight releasable attachment mechanisms that I described earlier. So we're going to install a little wedge at the base of that stanchion that'll lean that stanchion away from the ELC4. And finally, we're going to go install some what are called cedar rail stubs, pretty short little pieces of the MT rail out on the starboard end of the MT rail. We had previously removed those in order to be able to do some solar alpha rotary joint maintenance on a previous mission. We'll go reinstall those. Overnight again, after the crew comes back inside, we'll move the SSRMS back to the node 2 base point from the ground. And then flight day 6 will start up with the permanent multi-purpose module installation. In this case, Tim and Mike will be flying the Canada Arm 2. There is no handoff required. This is a direct unberth. If I could get the next slide, or the next video, please. So the first thing we'll do is we'll reach into the payload bay, grapple the grapple fixture, and then maneuver the permanent multi-purpose module to a low hover. Once again, we'll perform an operator-commanded auto sequence to get the PMM into what's called a pre-install config. In this case, we also have a camera system that assists the crew in lining things up, but instead of the camera being on the permanent multi-purpose module, it's actually a camera that's installed in the window on the Node 1 Nader common berthing mechanism hatch. You can also see that we're going to get a very good view besides the centerline berthing camera system right out of the cupola, because we're going to install this right next to it. We will then release, and then the arm will maneuver to its start position for EVA 2, which we'll execute on the next day. Brian mentioned the work that we will do before we get docked to survey the vehicle, if we have achieved a statement from the shuttle program and all the engineers that look at it by flight day 6 that says Discovery is good from a thermal protection system standpoint, that we don't need any additional inspections, then on flight day 6 we will activate and ingress the module. Otherwise, we'll activate and ingress the module on flight day 7. Also on this day, Tim and Al will once again at the end of the day get back into camp out in preparation for their EVA2 on flight day 7. And flight day 6 is a second part of our carbon dioxide removal assembly, R&R ops. We'll get one of the absorbent beds out and replace it with a new one that we brought uphill. Flight day 7 is EVA2. And again, Art Thomason will give you the details of that EVA later in the EVA officer's briefing. A couple of the points I'll throw out here is that the pump module itself contains about 10 pounds of ammonia that we need to vent out so that we can bring the pump module home on a subsequent vehicle in order to determine the failure case that caused the pump module to fail to begin with. We will also spend some time during this EVA recovering the lightweight adapter panel assembly, which everybody calls LWAPA, off of the end of Columbus to put that in Discovery's payload bay for a return to Earth. The lightweight adapter panel assembly has been the base location for numerous material science experiments recently, and there's an avionics box on that platform that has some of that additional science data that we'd like to get on the ground. Additionally, that platform will be refit and reflown for another payload sometime in the future. Also on this EVA, we'll be installing camera lenses on several of the robotics cameras. These are little protective lenses that go over the cameras. We'll install those on one of the Canadarm2 cameras, one of the special purpose dexterous manipulator cameras, and on the payload ORU accommodation, the POA that's out on the MBS. Flight day 8 is a half crew day, but we still have a couple of things we want to get done. By this time in the mission, we'll be ready to put the carbon dioxide removal assembly back into its rack in node 3. Should point out that we have 2 carbon dioxide removal assemblies on the vehicle now. The one in the lab will be running continuously. We've normally always run the vehicle with 1 Seadra, and now we have 2. So we'll take advantage of that to do this CO2 absorbent bed change out during 133 by taking one of those down. We also have our last-minute mid-deck transfers, and we have some packaging material that's inside the permanent multi-purpose module that we need to get out for return, to return some items home in Discovery's mid-deck. Then on flight day 9, once again, we have a half crew day. There is a joint news conference on flight day 9. I'm sure all you folks will be interested in that. We'll do the farewell, and then we'll also get the hatches closed, get the vehicles buttoned up for undock on flight day 10. And from here, I'll turn it back over to Brian for the rest of the mission.
Okay, thank you, Royce. So we got the hatches closed on flight night 9, and we're moving into flight day 10. The morning of flight day 10, the crew will wake up. The hatches will be closed, so go ahead and execute the undocking. If I can go ahead and roll the video, number 4 there, to show the undocking. Our pilot, Eric Bowe, will fly the space shuttle out to about 400 feet along the V-bar. And then he'll execute a fly around to get some good pictures of the space station on the outside of that, and then we'll do a separation maneuver, and Discovery will depart the vicinity of the International Space Station. Once that activity is complete, then the crew will go ahead and pull out the OBSS, the Orbiter Boom Sensor System again, and they'll do an inspection of the wing leading edges, the reinforced carbon-carbon, as well as the nose cap. Mostly here we're looking for the micrometeorite orbital debris type damage, so we won't need to go back and look at the back side of the vehicle. We'll just look at the forward part and looking for any little kind of damage that may have occurred from some of that debris that may be flying around up there in orbit. Again, all this imagery will be downlinked to the ground. That same team of engineers who now knows exactly what Discovery's wing leading edges look like on orbit will go compare to that baseline, and they can do a bit quicker assessment because they have that baseline to look at. So we'll go look at all that, verify it's all good, and again, report back to the MMT what they have going there, which obviously we hope is very little. The system should be all cleaned up. Once the crew is complete with the scans and the reviews there, they'll go ahead and park the Orbiter Boom Sensor System on the starboard sill. They'll park it for the rest of the mission, and then they'll park the shuttle robotic arm also for the rest of the mission. And there at the end of flight day 10, we'll be done with the robotic operations. And it was a very busy flight, as you saw, with the, both the station and the shuttle arms doing a lot of activities. There it goes. Bring it on down. So once we're complete with that, the crew will go to bed on flight night 10. The next day, the entry team will come in, with Tony Sakachi and his team will come in to do the checkout of all the entry critical systems to verify that they are all ready to go for entry the following day. So they're in the flight day 11 entry checkout. We'll check out the flight control systems when we fire up one of the auxiliary power units to power the elevons and the speed brakes and all those systems that are critical for entry, and verify that those are all working just as they should be. We'll also do a reaction control system hot fire, verify that the primary reaction jets are working just fine. And any other final activities we got to do, such as cabin stow, stow the KU antenna, and generally get the vehicle ready for entry the next day. So the crew will go to bed then, and on flight day 12, Tony Scotch and his team will come back in to prepare for the deorbit burn. For the deorbit burn, for this particular one, we'll close up the payload bay doors, just like we have every other time. And after flying around the Earth about 170 times, is what we're going to get with this mission, Discovery will come home for its last flight. Also on this flight, we have the boundary layer experiment DTO, and this is where we have the little half-inch protrusion on the bottom of the orbiter. I think Mr. Shannon spoke to you about it earlier. We're going to gather data around Mach 18, Mach 19 when we get the boundary layer transition on what thermally occurs with that little protrusion downstream of it, and what the all the data that the folks get from that. They got the catalytic coating on some of the tiles. Some of the tiles don't have the coating. Be able to derive what's going on in those types of scenarios and play that into future programs. The final landing of Discovery will occur at the Kennedy Space Center on November 12th, about 10:39 Eastern Time in the morning. We're all really excited about this mission. As I think we've laid out for you, the folks are really ready to go. We've got a good plan to go execute. It will be a very busy mission, as always, but the crew is ready to go. The team on the ground is ready to go, and we're going to go fly this one and come down home safely on November 12th. I think that's all I got, Rob, if folks got questions.
Thanks, Brian. Thanks, Royce. We'll take questions here in Houston, then go around to the other NASA centers, and I believe we'll start off with Mark in the back.
Oh, thank you, Mark Carreau from Aviation Week. And I have two questions. One for Brian: what triggers the additional day if it's available to you, and what would you do? Okay.
In recent flights, we've carried consumables to allow us to stay an extra day while docked. It's a dock day since we have the SPITS capability. We call it a dock day. In some flights, there's things that are pre-identified. Well, this is going to be a real challenge, and we're kind of worried about that task, and we may need an extra day to get that done. On this particular flight, we really don't have anything on that list. Most of the activities are pretty well defined. We think we understand them pretty well. Of course, we'll see. But we've trained them. We're ready to go execute. So on this mission, there's no pre-identified task that is in question. Only the usual sorts of contingencies that might come up, some sort of damage during ascent, inspections, repairs, and or some of the other challenges we may have while docked, and what we want to help out the International Space Station guys with.
Thanks. I had a question on the changes to from Leonardo to a PMM on the external shielding. I just wondered, how did you determine how much shielding you needed for the multi-purpose logistics module to make it permanent, so to speak? Is it based on a length of time or a position on the space station? How did you sort of weigh how much to put on to deal with the risk?
Sure, and what we've done with the permanent multi-purpose module is upgraded it to get it to be compliant with the rest of the modules on board on the U.S. modules that are on the vehicle. What we did there is took the hard shells off after 19A landed, and took the Kevlar blankets that are underneath the hard shells and upgraded the amount of Kevlar that is in those, and then put all those blankets back in, put the hard shell back on. We have folks here that do risk assessments for us to look long duration, 10 years out, What is how often are we going to run into micrometeoroid orbital debris, and what is the amount of protection that we need to add to the module in order to be able to protect the module from being penetrated in that case. So what we've done is taken a module that's only been designed and look at all those risk assessments that's only been designed to be on orbit for 2 weeks or so, and expanded that to say if this same module was on orbit for 10 years, what would we have to do to upgrade it to make sure we're in a good config for that long duration mission.
Robert.
Hi, Robert Perlman with CollectSpace.com. I think to follow up with on Mark's question about Leonardo, just to verify, are there any constraints on the ISS crew once it's attached in terms of how they can spend time in that module? Does it have any difference from other?
No, there aren't any constraints on how much time they can spend in the module. I think the natural flow of activities in the module will determine how much time they actually do spend in there, because really it's for stowage and food and water and pieces of equipment that we don't normally have our hands on. So I don't expect them to spend a whole lot of time in there to begin with, but there aren't any constraints on that.
And also, just to fact check, is it retaining its name Leonardo, or is it called PMM, or what? How do we refer to it in stories?
I will refer to Mr. Navius on that because I don't know the answer. It's the Permanent Multipurpose Module.
Affectionately known as Leonardo. So it will retain its name Leonardo for the purpose of engineering documentation. It's the Permanent Multipurpose Module.
And for Brian, given this is the last flight of Discovery, is there a sense among the team that this is that this has an importance to it, that it is a last flight? Is there, or is it just we fly the missions and there's time to look back later?
I would say it's a lot of the latter. The shuttle teams, at least the flight control teams, are very focused on going and flying the mission. We got hopefully 2 more, so we're fairly confident and can reflect later when we get out there. I'll also share with you, this is my 14th mission with Discovery. My first mission with Discovery was STS 31, which was a long time ago, obviously. But that was a flight we took Hubble up. And at the time, I'll go ahead and give you a war story because you guys sometimes like those things. At the time, are you scared? At the time, this was the first flight that we went and filled the OMS tanks. I was a consumables officer. I was in the back room. And it just, one of the many lessons the Space Shuttle program has shown us, just one of the gazillion, there's a gazillion of these lessons out there, but this is one of them. So we fill up the tanks all the way because we want to go as high as we possibly can so we can leave Hubble up and as high in orbit, so we'll stay up there as long as it possibly can. So we all agreed, oh yeah, sure, we can fill up those OMS tanks, no problem. So we have oxygen fuel on each side, an oxygen fuel tank on each side, left pod, right pod. And during ascent, of course, the team is monitoring all the tank pressures. This is specific to the prop group, monitoring the pressures, make sure the tanks are in good shape. Of course, in our training simulations, the training guys teach us lots of things, one of which is how to deal with prop leaks. So they put in leaks in the tanks, in the system. So you see the pressures bleeding down. And then we run through our procedures, respond to that, do what we have to do to deal with that particular malfunction. On this particular flight, we filled up the tanks to full, so there's a little bit of helium at the very tip top of the tank, but mostly liquid, fuel on one side, ox on the other. And what we learned in real time is that the oxidizer tends to absorb helium. The fuel tank pressures all stayed very steady, up around 275. The ox tank pressures on both sides, and thankfully we had 2 sides to compare, but they started bleeding down. They dropped about 10 psi, if I remember right. It's a long time ago. But they dropped about 10 psi during launch. And at the time, we're going, oh, is this a leak? Or is this just normal? Like I said, there were 2 tanks. They were both doing the same thing, so it made it a bit easier to call that not a leak and not respond to that. But it was just one of the many lessons that we learned throughout the history of Discovery and the Space Shuttle program on some of the unique challenges you get when you fly in space. And these lessons are all over the place. Every discipline's got them. Many of them occurred early in the program, but we're still learning lessons as we go. We got the boundary layer experiment I mentioned earlier. We're going to learn a great deal about how we're continuing to learn more about the dynamics of hypersonic flight and what that can do to you, the vehicle that you're flying at those velocities, and what it can mean to the crew on the inside. So we're excited that we get to learn all these things. Every new program that comes along, of course, has a huge bow wave of lessons to learn, and that's part of the challenge of a new program. Even before they get off the ground, there's all kinds of challenges and concerns and worries. But as you fly and you fly and you fly, you learn things, you get better and better. And it's just like cars today. We're all very familiar. Cars drive very well. I saw recently where a particular company is trying to get automated cars out on the roads and has been doing so. A lot of lessons to learn there, but cars are a pretty well-known thing, so you can design those systems, I'm not going to say easy, but at least easier. Flying in space, of course, has many unique challenges. This will be the 133rd flight of the Space Shuttle program, I believe, and every flight we learn things. So we're looking forward to this. Are we reflective? Somewhat, perhaps, but mostly focused on getting the mission accomplished and being sure that we bring the crew of Discovery home safely on November 12th.
Bill.
Bill Howard, CBS. So two from me for Brian, I think. You mentioned focused on the mission. John talked a little bit earlier about layoffs at the Cape and system-wide. How has that affected mission control, and how do you see the, you mentioned focus. There are a lot of distractions out there and morale issues. How are you guys handling that in the MOCR?
Great question. We are focused on the mission, and what I'll tell you is that the team here in the control center and across the country on the Space Shuttle program is an extremely dedicated and professional team. We're all passionate about what we do. So yes, we know the end is coming, the end of the Space Shuttle program is coming, but we are passionate and absolutely dedicated to making sure that the final flights are just as safer actually, because we know a lot more about how to fly the thing, safer than the first few flights. So the folks are working really hard. There are distractions there, but we are professionals and we're dealing with those distractions just like you would deal with any other distractions.
And I know you're not lead flight director here. I noticed that 20 minutes ago, the National Hurricane Center did Richard Jones, your ascent flight director, the honor of naming the tropical storm after him. That looks like it's going to come over the Florida Peninsula here around countdown time. Have you guys even talked about this in terms of if those tracks actually play out, what some of your options are?
Hurricane Richard is coming? Is that what you're saying? Actually, Rob showed us the plots of that just before we walked in there. I had not seen it. But I've lived on the Gulf Coast my entire life, and hurricanes come and you deal with them, just like we did with Ike, just like Florida has certainly had their share of hurricanes. And we'll monitor, see what happens. And if we got to roll back, I really hope that's not the case, or the folks at KSC have all their contingency plans in place to deal with if those ground tracks come towards them, what the timelines for those, I don't remember all the details, but they have all those plans in place and are ready to deal with it if we have to. I'll remind you, however, hurricane predictions are a challenge. It's a kind of an art, not a science. So as observing them over the Gulf Coast for the last 40 some odd years, wait and see. We'll see what we get. We'll be ready to deal with whatever Mother Nature wants to throw at us.
Yeah, I live there too, so I know what you mean. For Royce, really quick, you may have mentioned this, and I may have just missed it taking notes. What's the total up mass on PMN and ELC-4 in the bay as you launch?
I don't want to quote the number right off the top of my head. It's on the order of 28,000 pounds. We can get the detail for you.
Thanks.
Gina.
Gina Sinceri, ABC News. Two questions. One, let's start, Brian, since you told us a little bit about your history with Discovery. Does this mission, since it's Discovery's last mission, have any poignancy for you?
Again, it just signifies the end of the Space Shuttle program is that much closer, and that reason, of course, we're all interested in making sure these flights all fly out very well and very safe. And as always, with every mission, the crew is our prime concern, making sure they come home safely, and that is what we're going to do. So I don't think it's any extra significance necessarily, but our job is to continue to be professional and focus on the mission, make sure those guys come home safely.
And Royce, does this mission complete the space station?
Well, we have as the next mission coming up, bringing the alpha magnetic spectrometer and the rest of the equipment that it has on it. So I would say we're almost complete. This mission does fly, as I said, in the last pressurized module that will be installed on the U.S. segment with the addition of the permanent multi-purpose module.
Did you?
Yeah. Eric Berger with the Houston Chronicle, and I think the PhDs at the Hurricane Center may quibble with their craft being called an art rather than a science.
I don't know.
But for Brian, given that this is almost certainly the last flight of Discovery, is there anything different you're doing in terms of bringing the vehicle back, steps you don't have to take because you're not preparing the vehicle to fly again? or is everything going to be by the book as it has been with every other mission for Discovery?
It's the latter. Everything will be by the book as we've done the previous missions. And you bring up a good point. Years ago, in the mid-90s, we had these, between flights of each vehicle, we had a long list of maintenance items that folks at KSC would take care of. And we went and scrubbed those lists and said, well, shoot, what can we take care of while we're on orbit to save the time on the ground? And we came up with a long list of stuff, and we execute those every flight so that they don't have to turn around and do it on the ground. And we will continue to do that. We didn't go scrub those things out of our procedures. We're not doing anything different on this flight than we have in the previous, so we'll do all the same checkouts that we normally would do. All of that intended and designed to bring the crew home safely, just as we have done on the previous flights. Don't do anything different. Do it the same way you've been doing it, because we know that works pretty darn well.
Thank you.
All right, let's take a question from Mark, then we'll go to the other centers.
Hi, Mark Kirkman, Interspace News. This question's for Royce, and I'm not sure how much you can tell me, how much exposure you've had to it, but can you describe the Dragon Eye LiDAR system that you're bringing up? It's my understanding for SpaceX. Does that mean that it's not a program asset, it actually belongs to them? Can you tell me just an overview of how it works and what's envisioned to be gained from that?
And I'll defer that answer to Brian. I will tell you on the ISS side that we're collecting some GPS data for the rendezvous and undock that we'll provide for them for some post-mission analysis. But the equipment in the payload bay, I'll let Brian deal with.
So to answer your question, I think we flew it previously in STS 127. It's a box. I think of all these avionics things as that's a box, there's a box. It's a box that sits in the payload bay next to the orbiter docking system. And the crew flips a switch to turn it on flight day 3, and they flip a switch to turn it off after we get docked, and we'll turn it on and off, same for undocking. It's a LiDAR, it's a laser, it's collecting ranging information. It's got a GPS on board this particular one, and they're collecting data for GPS as well, which is what they will use post-flight to compare to the space station GPS. It is purely owned by SpaceX, and we have very little interface with it other than that switch throw. We turn it on, we turn it off. If there's issues, problems, we won't know in real time necessarily, nor will we troubleshoot any of that.
Okay, and I don't know if it makes you happy with Oregon, but I do know you're leaving one of the handhelds behind. What's the reasoning for that?
ATV or HTV? HTV. We were asked to leave one of our handheld lasers behind, which is a handheld little device they use to shoot at an object and get a range and a range rate over time, of course. We were asked to go ahead and leave one of those on board as a backup to a backup probably for when the HTV comes flying in. The crew will have that if they want to pull it out and use it. And I think we did a similar thing after STS 128. We left one up there and brought it back after that.
Okay, let's go around to the other centers. We'll come back here to JSC for follow-ups and down to Discovery's launch site at the Kennedy Space Center.
This is Marcia Dunn of the Associated Press. For Brian, couple questions to start with you. Have you had a chance to reflect with your father perhaps the parallels or similarities or not between the end of the shuttle program and the end of Apollo? I was wondering if you could share a little bit of that, please.
That's a good question there. Probably not in those specific terms. Of course, my dad and I talk a lot. Dad was involved in the program in the early days, and he was also shuttle program manager. I think it was for STS-2 and a few flights thereafter. So he has certainly been involved in the early days of the shuttle, the latter days of the Apollo, and he's still paying attention. Obviously, he's still in the neighborhood. He still comes and visits. I saw him in the cafeteria yesterday. He was up here doing some other things. So Dad and I often get a chance to talk about various things, and I got to say our biggest concern, of course, is the future of manned spaceflight. He got involved in spaceflight because he thought it was good for the country, good for the world, and I got to say that I have the same motivations. We think what we do is important, the science we collect, the lessons we learned, and just the exploration benefit of having mankind doing these things is a must, in my opinion. So he got involved for those reasons. I'm involved for those as well. And ending the shuttle program with the gap coming up and some of the other things going on, we are concerned that what we've invested our lives in, we want to make sure that it continues to go well. So there's lots of other opportunities out there, of course, and we'll go explore those and see how those happen. And as far as the end of the Apollo program, we haven't specifically talked about that. We've just talked about what's coming next, and we're looking forward to what that is and hoping that it's all going to turn out well.
Thank you. And I'm wondering, Does Mission Control or the crew plan any special commemorations during the flight because this is Discovery's last flight, or any special payloads or that are going up specifically to mark the end of Discovery's flying time?
Yes, I think you'll see, similar to an STS-132, when that crew thought that could have been it was the last planned flight of Atlantis at the time. They did a little tribute, if you will, a video where each of the crew said a few words. I expect we'll see a similar thing on this flight, probably flight day 11 or flight day 10 after undocking. They'll share with us some of their thoughts and reflections, so something to look forward to.
And for Mr. Renfrew, I know we have a Robonaut briefing coming up, but from your perspective, once the Robonaut container goes over to the space station, is it opened up at all during the shuttle visit, or when does it get put off to in terms of whatever happens to Robonaut from once it gets on board?
Yes, actually not any time during the mission do we intend to deploy the Robonaut. The stand and the upper torso of the Robonaut stays in the permanent multipurpose module all the way through the dock time frame. And then during the increment ops, after 133 is gone, we'll get it out, assemble the two components together, and start doing some investigations into that science program on board ISS. I believe the destination location for that is in the U.S. lab.
Do you have a timeline for that, even ever so vague? And are you personally excited about the prospects of what Robonaut has to offer?
And I don't have a timeline. I have to tell you, I've been absolutely focused on this mission 133, and because I'm not deploying Robonaut, I haven't tracked it more than the fact that I know where it is in the PMM, and I know I don't have to get it out. It's exciting. It really is. Brian's been telling war stories all along here, and I have a young daughter. I like to tell her that all of the stuff that I used to watch when I was a kid growing up, as far as science fiction and all the books I used to read, are apparently coming to life here. So it's a very exciting demonstration technology that we're going to get on board ISS. And I know those guys have been working for years over in one of the buildings here in JSC. I've wandered through that for years now and saw the Robonaut get assembled, and to finally actually see it get launched and start using it on ISS and learn how we're actually going to operate it and how we can fold it into our normal operations is a very exciting activity. And as you said, there is a detailed Robonaut briefing by the experts who can give you all of those details a little bit later this afternoon.
Hi, it's James Dean from Florida Today. I have 4 questions that I think may all be for Royce. First, if I recall correctly, the installation of that power extension cable was something that was initially planned during the pump module R&R and was considered a prerequisite to installing the PMM. And I was just wondering if there was some problem on EVA-1 getting that installed. I don't know how simple a task that is, but if there was some problem, would that impact your ability to install the PMM the next day?
We had originally planned to install, it's the J612 cable that I mentioned in my briefing that we're talking about here. We had originally flown that uphill on, I want to say, 37 progress. It came uphill, so we would have it to be able to do the stage EVAs that we had scheduled, stage EVAs 15 and 16. And we were going to go install that cable as part of those 2 stage EVAs. As we were going through the preparation to do those stage EVAs, however, we had the failure of the Lupe pump module. So the installation of that cable, while it was a high priority task to get ready to go fly 133, was not as high a priority task as actually to R&R the Lupe pump module so we could restore nominal external thermal control system cooling. So during the 3 AVAs that Doug and Tracy did to go change out the pump module, we simply ran out of time on those EVAs doing the higher priority tasks. So we absorbed that activity on 133, and that's, as I said in my brief EVA overview, that's the very first task that we do on EVA-1 before we get into any of the other tasks on the EVA.
Okay, I was also wondering why you couldn't bring home the pump module on Discovery or even the next flight. I assume it requires a specific carrier, like maybe an ELC or ESP or something. If that's the case, how will you get it home if the flight schedule allows you to do so?
Well, your musings there are perfectly correct. We need a particular carrier to bring that home, whose name escapes me at the moment, actually. But a particular carrier in the payload bay, and at the time the pump module stuff all came up there in August and September, we took a quick look at it and just knew at that point there's no way to rearrange the payload bay to fit that carrier on Discovery with the other items that we had in the payload bay. Looking ahead to 134 is a similar answer. The AMS is sitting back there, and there's not room to put that carrier. So for 135, they're shuffling things since it's far enough away where we can go and figure out how to put that carrier in the payload bay. So it's expected that for 135, assuming that flight is approved and authorized and appropriated and all those good things, and if we get to go fly that flight, that we'll be able to bring it home on that particular flight with the right carrier in the payload bay.
Okay, Royce, normally with an MPLM mission, you have a hectic schedule of transfer of stuff, in and out of that module. Obviously, with it staying up there now, assuming that's not as much of a factor, I just wondered if you could describe kind of the transfer activity, how busy that will be on this mission, what is getting transferred, if anything. I know you mentioned some packing materials or something, but how that will compare to MPLM missions we've seen in the past.
Sure. So nominal MPLM mission, I think you described that accurately. It's a hectic schedule to get all of the new hardware out of the MPLM, stow it somewhere in ISS, and then get all the old hardware, the stuff we want to bring back home, stowed back in the MPLM during the dock phase so we could put that module back in the payload bay and bring it home. I think the answer to your question is we still have a very hectic schedule doing a lot of other activities. They just don't happen to be transferred because we don't have to empty the module. We have multiple R&R activities, in-flight maintenance activities that we're doing. We have the 2 EVAs that we're going to go execute and 2 big payload installations. So it's a very busy mission. It's just not busy in the fact that we're transferring cargo back and forth. All told, we have about 30 hours of mid-deck transfer on the mission. The CO2 absorbent bed coming up in the payload bay, coming up in the mid-deck that we're going to replace for the carbon dioxide removal assembly, bring the old bed home. We're also bringing up that water on-off valve I mentioned that goes in the Columbus module. Another big item that we're bringing home in Discovery's mid-deck is the hydrogen dome that comes out of our oxygen generating system that failed previously. We replaced that with a spare. We're bringing that failed hydrogen dome home in Discovery's mid-deck, but the packing for that actually comes uphill inside the permanent multipurpose module. So that's what I was referring to before. We'll go get that packing out so we can get that H2 dome on the ground.
Okay, thanks. And finally, Royce, just thinking about the debris shielding for the PMM. I was thinking about how you rely to some extent on the shuttle fly-arounds to get an assessment of the station's condition after each mission, and as I understand that helps you to really detail where you may have things like debris strikes and any kind of issues around the station. I was just wondering if, looking forward, if you could speak at all to, how you'll be impacted without shuttle fly-arounds to help. How well will you be able to monitor the station's exterior condition and potential debris strikes?
Sure, and that's we still have 134 coming up in the first part of next year, and then hopefully a 135 mission also next year that'll be able to help us at least do a baseline for the ISS config, in particular for the permanent multipurpose module that we're going to install on this mission. We do get tremendous benefit out of the orbiter fly-around because we've done it for so many missions, and we can go back and compare the orbiter fly-around from mission X to mission Y to see if there's a ding on the vehicle from micrometeor or whatever. However, we also do have a tremendous amount of camera assets on board ISS, including the mobile assets that are from the Space Station Remote Manipulator and from the GEM RMS as well. So we do a lot of surveys during stage ops where we're looking at in particular things. So yes, we'll we have learned a lot. Brian talked a lot about what we've learned in doing human spaceflight. We've learned a lot about how a structure that big behaves in space by looking at the data that we gather from the orbiter fly-arounds. But we'll continue to learn that after the orbiter stops flying by using the assets that we have on board ISS.
Okay, we'll go to NASA headquarters for questions before coming back here for follow-ups.
Hi, this is Denise Chow from Space.com. Just a question about the PMM. I'm wondering if you could outline the interior changes, the most significant changes you made to the interior of the module, and specifically what type of hardware you eliminated to reduce the weight.
Sure. One of the big things that we took out there was the internal thermal control system. Most of the ISS modules that have an active thermal control system, we flow water through various loops. The water on-off valve that Scott's going to change out for us in Columbus is part of that system. In the permanent multi-purpose module, we don't have an active thermal control system. We have shell heaters that are strung out around there to keep it warm, but we're not actually flowing any water through the system to be able to cool off any racks. So we took that equipment out. That was one of the big weight savings that we took out of the module in order to be able to get additional payload in it. We also, as I said, modified some of the avionics racks, the avionics fold-down containers inside the PMM to allow the crew to be able to fold down the hatches to get to those avionics boxes without having to disconnect a bunch of cabling. It's pretty easy for the guys at the Cape to do that when we have it on the ground because the module's powered off and you can just disconnect all that stuff. For a module that we want to presumably keep up and happy while we're doing some activities, we don't want to have to power it down. So we extended some of those cables to make those IFM tasks a little bit easier. We've also gone through and taken out the wiring that would be necessary for an ATU, an audio terminal unit. There's not one in the module, and there's also not a utility outlet port in the module where the crew would plug in a laptop if they needed one. Again, with the idea here that we're not doing science and we're not doing payload activities in this module. It's really just for putting in equipment that we don't need, and we don't spend a whole lot of time in there.
Okay, we're back here at JSC for final follow-ups in the back.
Philip Sloss with NASAspaceflight.com. Question for Brian. On the boundary layer DTO, I understand that you want to avoid doing a role reversal during the period where you might trip the boundary layer. Is that going to have any operational limitations in terms of, I think I also saw that there might be some cross-range limitations for entry?
Right. So what you're alluding to there is we have identified when we expect the boundary layer transition to occur. It's around Mach 18, Mach 19. And we've also identified which cross ranges would cause a role reversal to occur, because your cross range predetermines when your role reversals will occur. So we're going to try to avoid those if we can. We may consider doing orbit adjust burns to help that. Tony Sacacci and entry team will go through all those calculations once we get on dock to see what's available. Our number one priority, of course, is to land at KSC, to land safely, and we have a list of other things we do consider for those orbit adjust questions. So if we can accommodate it and still accommodate all the other things, we may target an orbit adjust type burn to improve that first opportunity at KSC's cross range for this experiment. But then, as you know, weather may be a problem. We may not land on that opportunity, and we kind of take what we get on the subsequent opportunities. So again, Tony and the team will go through all those discussions and determine if it makes sense, given everything else that's going on, to do an orbit adjust type thing to try and optimize that particular cross range for the first deorbit opportunity, and decide whether or not to do it.
That's it.
Okay,
Thanks.
Any other follow-ups here? Okay, no other follow-ups. So our programming note coming up on NASA television, our pre-flight briefings will continue later today with the spacewalk overview briefing featuring lead spacewalk officer Art Thomason, followed by the Robonaut 2 briefing with Rob Ambrose providing all the details of the humanoid that will reside aboard the International Space Station. Following that, Discovery's 6 astronauts will be here for the traditional crew news conference. So stay tuned throughout the day on NASA TV for all of those briefings. You can follow Space Shuttle and Space Station activities on our website at www.nasa.gov. With that, we'll look forward to the rest of today's briefings. Thanks a lot for coming.